Hello again, nerds, and welcome to episode 3 of the Pacathon tutorials. You can see right now I'm training up my neural network, and we'll say it's doing pretty good. And we're going to learn how we can save this network so we can save all of this really good info and keep it for our next training session. So right now, when I press X, what happens? Did I just lose everything? Is all of that gone? Right? If I exit out of the program, what do? Well, you're not lost. You're good. If you go over to today's date in Saves folder, so you can find all this. If you go to the Assets folder and then Saves, you can navigate to today's date and the most recent number, so the biggest number. If we go into this folder, you can see that we actually have every single generation that we trained saved. So even from our first generation, we've been saving all this data. This means that the most recent generation, 10, has probably the best data. But if I were to just format this file, and this will take a few seconds because it's a huge file, we're going to see that it's kind of a lot of gibberish. Like, it's not very useful to you. It's just this giant block of JSON. See, if I scroll around, I have to scroll past almost 100,000 lines to get to the bottom. It's not good for you. It's not useful. Don't look at it. Instead, we should figure out how we can use it. Okay, let's figure out how to use it. If we collapse everything, or actually, before we forget, we care about generation 10. All right, let's remember that, generation 10. So if we go into the core folder, and then we check out the source code, and go into the main class, and just like all the other times we've been in here, let's, for simplicity's sake, collapse everything. So we just care about this create neat method. You'll remember from last time, we were working with this neat here. But we also have this neat over here. We can, instead of creating a new neat instance and starting from generation 0, load an existing one from file. So all we need to do to get this to work is, first of all, enable it. We have to set this false to true. And then we have to check that to make sure our exact file is correct. So if you'll remember, we were in the saves folder, and then October 21-2, not 1, and we had generation 10. Okay, if I save that, and I'm going to comment out this code for now because we care about this later, we should be able to load this from scratch. So let's try it. If we go into a terminal again and type gradlew, lwjgl3 run, we should see that we can load our neat from a file. Unless we got the name wrong, in which case it'll spit an error at us. But let's keep our fingers crossed here. Alright, looks like I put the name in wrong. Invalid file. I guess it was generation 9 instead. Let's double check this. If we go into assets, then saves, it's actually October 22nd-2. That's my mistake. So we can change this October 21 to October 22. All right, let's try this again. Gradle lwjgl3 run. And this time, we will see a window pop up, and we won't be starting at generation 0. Let's hope this works. All right, as you can see with these Pacman, they're training like they've already had a lot of information. And we can confirm this if we go into the terminal. You see that we're on generation 11 already. So we've skipped the first, say 9 generations because we started at generation 10. All right, well, that's perfect. That's working as we want it to. But this maybe isn't the most helpful, because if we are in our old training session, right, if we press tab, we can see that we have our 5 inputs like before, right? We have the 1 bias input and the 4 directional inputs, right? Up, down, left, right. But those, what if we wanted to add more, right? The whole point of saving our old instance and then being able to load it later is that we would do different experiments with, say, different information. So how do we add more inputs to something that we loaded from a file? Well, it's actually not so hard. We can quit this, and I'll clear out everything just to be thorough. We have this method over here. So if we comment out this line, we have our neat implementation dot update node counts. And this lets us basically override any previous value, and it adds, say, from 4 to 5 input nodes. And in this case, we just keep the same number of output nodes. A quick distinction here, you'll notice that we already had 5 input nodes, but that's because we always add 1 in for bias. So don't be fooled. We only have 4 important nodes, but we have 5 in total. So when we set this count input nodes to 5, we have 5 important nodes and then 6 in total. All right, but if I run this, we're going to run into an error, right? So let's try. If I run this, we're going to have the panel load up with all the Pacman, and then after a couple seconds, it'll just go away. Because what'll happen is we have added in a new node, but we haven't actually added information for that node. So you see all these errors getting spit out. Let's stop this before I spam my console too bad. And how do we fix this? Well, we can actually close out of everything and then hop on over to our core folder and source code and hop over to that neat behavior we've been working on for a while. Right? So we go back to the neat Pacman behavior. And in here, we have, of course, all of the information that we've been trying to give our neural network, but we can expand it a little bit. So you can see right now we only have the 4 main bits of information. But remember, we changed it, so it's 5 now. What we can do is add in a new input. In this case, I'm just going to set a random number in, which is just for example. In reality, you'd probably set to, say, 8 bits of important information instead of 5, and show which direction, say, the ghost is in, or the pellets are in, or any other information you want to go for. You can also set it to a really big number, like 1,000, and maybe show every single tile on the board, and whatever else you want to try. But for now, we're going to say random number is equal to, well, a random number. And we can pass this into our network here in this array, so random number. And now we have our 5 inputs, and we have updated or lobotomized all of our neural networks to have 5 inputs as well. So now what we should see when we run this is we are starting from a already good population because we did our pre-training, and then we're going to lobotomize all of the neural networks. So let's see if that worked. All right, well right now it looks like we have some pretty good Pacman. They've still learned, they're pre-trained, but if I press tab, you'll see that we now have 6 total nodes, right? 5 important ones, 1 bias one, and you'll see that the new one is the top node, and it's not connected yet. This is because we lobotomized the neural network, right? We just added in this new node, and we haven't actually trained in any useful information yet. So we don't technically know if this node is good for any specific use case yet. And that's what Neat will figure out. So if we give it a couple generations, we'll start to see this random node get connected to a couple different nodes, and it seems to be helpful because it's getting trained in over time. So now if I press tab, we should see we're getting a little bit better. You'd be surprised. Giving a random number is actually somewhat useful in this case because it helps Pacman take a random path, but it really is showing how bad our information is if we need to give it a random number to succeed. All right, so that's all you need to know to save a neat to file. But of course, we just did all this training. We could do this again. If we exit out here and we close, you'll see if we hop over again to the assets folder and then the saves, we've created a bunch of new folders, right? Our most recent run was October 22-5, and you see we started off at generation 10, and we trained for 8 generations on this random node. And we can train off of this now if we wanted to. Just like before, all you need to do is go into the main file and update the file path, but I won't bore you. Hopefully you'll be able to use this trick to try a bunch of different experiments, put in any new bit of information without having to wait a really long time to train in the base behaviors. All right, well, I can't wait to see what you all build with this. Good luck.